right, homework 35, we are going to construct the vector 1.8a plus 1.4b, having an initial point of b. So again, we're going to use these tools on Alex to move our vectors and scale them. What you're going to do is take the first vector, move it so its end point is on p. So in this case, I'm going to move the end point of a to p. So I'm going to grab this vector, I'm going to pull it over here. It's still going to be the same size. I'm just going to move it over. Then I'm going to scale it to whatever it says. In this case, 1.8. So I'm going to stretch that vector out so it's a little longer, and so now it's going to say 1.8a. Next thing you're going to do is you're going to move the end point of B to the end of A. So I'm going to grab this vector. It's going to plop over here like this. It's still going to say 1.0b. Then I'm going to scale it to whatever that says there. In this case, scale to 1.4. So I'm going to drag that out so it's just a little bit longer, and now it's going to say 1.4. Final part, you're going to draw the vector from P to the end of B. So I'm going to take a different tool. It's just going to look like the vector. I'll show you in a minute, and draw from P to the end of B, and that's what it's going to look like when you're done, is this vector right here that I have drawn in black. So I'm going to show you one on Alex here. So I'm going to clear this out and go over here to Alex, and just using the one that they have here so you can see me using the tools. First thing I'm going to do is I'm going to move vector B because it says 0.7b first. So I grab this tool with the hand, I grab vector B, I put it right on point P. So now I've got 1.0b end point on P. I'm going to scale that to 0.7. So I'm going to grab this middle tool with the two arrows, grab the end, push that back until you're at 0.7. If you click in the gray area, that turns off your tools and you can see what you've got. So right now I've got 0.7b. I'm going to add the 0.8a. So I'm going to grab the move tool. I'm going to grab that. I'm going to put it on the end of B. Not on P, on the end of B. So I move that over there. So I've done B, I'm adding A to it. A's got to be scaled to 0.8. So I grab my scaling tool, I smoosh that back until it says 0.8a. Click in my gray box. So I've got B, I've got A, B is 0.7, A is 0.8. I'm going to grab this end tool, which is to draw your final answer. And on your final answer, you're going to start at P, and you're going to go to the end of your second one, which in this case was the A, and your graph is going to look something sort of like that. If I check that, it says, hey, look at that. So going back to the ones we have on our paper, if I go to number 2, number 2, I'm going to do 0.9t plus 0.5s. So I'm first of all going to move t2 to p. So I'm going to take this vector, I'm going to pull it up here, it's going to say 1.0t. I'm going to scale that. I'm going to scale this one back to 0.9t. So I'm going to push it back just a little ways, and so now my vector here will say 0.9t. Then I'm going to move s to t. So I'm going to grab this vector here, I'm going to put it on the end of t. It's still going to say 0 or 1.0s. I'm then going to scale it to 0.5. So I'm going to take this end, push it in. So now my vector is at 0.5. Then I'm going to draw from P to S. So point P to the end of S would draw right here, and that's going to be my triangle there. My little extra marks where I scaled are not really going to show up there, and it's going to look something like this. This side will be labeled 0.9t, this side will be labeled 0.5s, and then I have my vector drawn from P to S. So on the next one, we are going to start with vector B. So I'm going to move B to P. It's going to kind of run into it, but I'm going to move it anyway. It says 1.0B once I move it. I want to scale it to 1.7. So in this case, I'm going to add on to it, make it longer, and now it's going to say 1.7B. Then I am going to grab A. I'm going to put A on the end of that. So this is going to point down this way. It's going to start by saying 1.0A, but then I'm going to scale it. So when I scale it, I'm going to scale it to 1.1, which makes it a little bit longer. Once this says 1.7B, that says 1.7A. I'm then going to draw from P to the end of A, and I'm going to have my drawing. Just for fun, I'm going to go back and do one more on Alex with my tools. So you can see again how they work. So I'm going to hit more practice here. So I'm going to start with 0.8c. This is my vector C. So I'm going to grab the move tool. I'm going to take C, plop it right on P. Once I've moved it, I'm going to scale it. It's at 1, I want it at 0.8. So I'm going to grab the end, push it in till it's at 0.8. By the way, I got to click to set it. Clicking in my box then, I'm going to add the D vector. So I'm going to take my hand tool, move D to the end of C. Then I'm going to scale it to 1.3. So I'm going to pull it longer till it says 1.3. I'm going to click. Now I'm going to finish drawing my vector. I'm going to take the vector tool, starting at P, ending on the D. And that's going to be my drawing. The next ones you're going to do are the vector subtraction. And again, when you think of subtraction, you think of adding the opposite. So I'm going to take A plus negative 2B in order to do this one. So this is the one that's on Alex just to show you the tools. Then I'll go back to the ones on our paper. And so on the vector subtraction, which would be 4, 5, and 6, we're going to change this to A plus a negative 2B, and then use our tools like we did before. So, I'm going to move A to the end of P. Move that over here. Now this is just going to stay 1A because there's no scaling to that one. A is the same thing as 1A. Then I'm going to move B to the end of A. Now B I want to make negative 2, and so I'm going to take that and I'm going to pull it backwards so that it's at negative 2.0B, which is the same thing as negative 2. Then I'm going to take my vector tool and I'm going to draw from P to the end of B, and that's all there is to that. So the only thing is here, if it's a subtraction, it's adding the opposite. So subtracting 2 is the same thing as adding a negative 2, and then I can draw my graph. So if we go over to the word ones where we have to construct them, same thing. We're going to start by moving A to P. So I'm going to move A to P. It's going to end up being right here. It's going to be at 1.0 until I scale it. So then I want to scale it to, this one says 1.4A. So I'm going to stretch that out a little bit. So now it's going to say 1.4A. Then I'm going to move B to A. So I'm going to grab that. I'm going to put it here on the end. It's going to say 1.0B, but I want to do 1.4A plus a negative 0.7B. And so since this is a positive 1.0, I'm going to take that, and it's actually going to push all the way backwards, and I'm going to keep going back until it says negative 0.7B. So this part will be gone, and it will end up going in the opposite direction. Now I'm going to, oops, I forgot to write here, scale to negative 0.7. Then I'm going to draw the vector from P to B. So here's point P. I'm going to draw it to the end of B, and that's what my vector is going to end up looking like. Again, this part won't show up after I moved it. It will look here with the end of A. B ended up being negative and going in the opposite direction, so I'll just see that little triangle there once I get to the end. So number 5, again, I want to think of this as negative 2A plus a negative B. So I'm going to start, move A to P. So it's going to start out and go like this. It's at 1.0A. However, I'm going to scale it to negative 2. So now I'm going to take it, push it backwards until it says negative 2.0A. This part down here is going to disappear. It's going to end up going in the opposite direction, negative 2. Then I'm going to move B to A. So B is going off this way, 1.0B, but I want it to be negative B. So scale to negative 1. So again, I'm going to push this backwards. It's going to end up being the same length, just going in the opposite direction. So now instead of pointing that way, it's pointing the other way. Once I have this one labeled negative 2.0A, this one labeled negative 1.0B, then I'm going to draw the vector from P to B. So starting at P to the end of B, and I'm just going to see that little triangle there when I'm done. One more of those, we are constructing 0.9A minus 1.7B. So move A to P again. So starting with A, I'm going to move it to P. It's going to be like that. It's going to say 1.0A. I'm going to scale it. So it's going to be 0.9. So it's just going to be a little bit shorter. I'm going to push the end back. And so now it's going to say 0.9A. And it's going to be a little bit shorter. We'll just say it ended there. Then we are going to move B to A. B is going this direction, 1.0B. But I'm going to scale it to negative 1.7. So again, I'm just going to push that backwards. And instead of pointing this direction, it's going to end up going in the opposite direction until you get negative 1.7B. So again, you won't see this bottom part because you pushed it backwards. You'll see A going to here, B going to here. This is going to be labeled 0.9A. This is going to be labeled negative 1.7B. Once I have those two vectors, I'm just going to draw from P to the end of B. And that's how you do those. So just to review that one more time using the actual ALEKS program. If I hit more practice here. Here I have negative A minus B. So I'm going to start by moving A. Instead of being a positive 1A, I wanted a negative 1A. So I'm going to push it backwards until I get to negative 1.0. Click to set it. So negative A is the same thing as negative 1.0A. Excuse me. I'm then going to move B to the end of that. Instead of having a positive 1B, I want a negative 1B since I'm subtracting B. So I'm going to grab that. Whoops, wrong one. Grab the middle one. Push that backwards all the way back in the opposite direction till I get a negative 1B. So now I have a negative 1A, a negative 1B. Once they're labeled correctly, I take my vector, I start on P, I pull it over to the end of B, and that's what I'm going to have when I'm done. It's a little slow at checking. All right, 7, 8, 9 are calculating the magnitude and direction of a vector, and just like most of trig, we're back to thinking about right angles and sine, cosine, and tangent, and all of those good things. So, magnitude of the vector is just how long is this vector. Well, if I draw my right triangle here, this side is negative 3, this side would be positive 6. So my vector that I have is negative 3, 6. We said to calculate the magnitude of our vector, we're using the Pythagorean Theorem, and we said the magnitude of the vector was the square root of a squared plus b squared. And so we're going to take negative 3 squared plus 6 squared, which gives me 9 plus 36, which gives me the square root of 45. Instead of simplifying the square root of 45, up here in our directions, it says round your response to 2 decimal places. So we actually have to calculate what the square root of 45 is. So I'm going to grab my calculator here. Square root of 45 would give me 6.7082. I'm rounding to 2 decimal places, so 6.71 would be what the magnitude of my vector is. Now that's only part of the problem. They want us to find the magnitude and the direction of the vector. So what they really want us to do is figure out what this angle is in here. Because I don't want to use a rounded off value, I'm going to use these 2 sides that they already have labeled. I have the opposite and the adjacent, so I can say that the tangent is equal to the opposite over the adjacent. So I'm going to do the inverse tangent of, and I'm going to have 6 over negative 3, which would simplify into negative 2. Now we are going to do our angle in terms of degrees, so make sure your calculator is in degree mode. If you're not sure, mode, and hit number 1. Otherwise you should see that little D up there on the top of your screen. It's in degree mode. So I'm going to do shift tangent to get inverse tangent of negative 2. I get negative 63.4349. Now you can see this angle is not negative 63. Negative 63 would be going backwards this way. So even though I get a negative answer, I'm going to put it in as a positive because I really measure my angle going this way. It's the same angle, just going in the other direction. And so for my answer, rounding off to 2 decimal places, I'm going to say that it's 63.43 degrees, and that would be how big theta is. So even if it does come out to be a negative, we're going to get the positive angle, 63.43. So number 8, again, I want to find the magnitude and the direction of my vector. This one here, along my x-axis, I would have 5. Along my y-axis, I also have 5. And so my vector would be 5, 5. The magnitude, I'm going to do the square root of a squared plus b squared. So 5 squared plus 5 squared. 25 plus 25 would give me the square root of 50. And again, we're going to do 2 decimal places, so we're going to use our calculator. What is the square root of 50? 7.0710. Rounding to 2 decimal places, 7.07 then is the magnitude of our vector. Finding our angle here, again we have the opposite over the adjacent, so the tangent or inverse tangent would be 5 over 5. So inverse tangent of 1 is what I want to do. So shift tangent of 1 gives me 45 degrees, and that is positive. This is 45 degrees here, and so that's going to be my answer. Number 9, same kind of thing. This would give me -3 in my x direction, -7 in my y direction. So my magnitude would be the square root of -3 squared plus -7 squared. So that would be 9 plus 49, which would give me the square root of 58. Again, I'm just going to use my calculator and do the square root of 58. So 7.6157 to 2 decimal places then. My magnitude would be 7.62 because I need to round that one up. For my angle here, again, I have the opposite and the adjacent, so the inverse tangent would be -7 over -3. So I'm going to do the inverse tangent of +7/3. So inverse tangent of, and I'm going to use parentheses because I'm not real sure on this calculator if I need them or not. So to be sure, I put parentheses around my fraction, and I get 66.8014. Again, that is a positive angle, so I'm okay there. So my answer is going to be 66.80 degrees for what the measure of that angle is. (10), 11, and 12 are finding the components of the vector. It says calculate the x component of the vector and the y component of the vector. So in other words, we want to find this distance here and this distance here, the x and the y. We know the hypotenuse, so in order to find x, we have the adjacent and the hypotenuse. So we would say that the cosine of x equals the adjacent over the hypotenuse. In order to find y, we have the opposite in the hypotenuse. So the sine of x would equal the opposite over the hypotenuse. So cosine of 54 is going to equal the adjacent, which is x, over the hypotenuse, which is 18. The sine of 54 is going to equal the opposite, which is y, over 18. So solving this one, all I'm going to do is 18 cosine of 54. Solving that one, I'm going to do 18 times the sine of 54. So 18 cosine of 54 is 10.5801. I'm rounding to 2 decimal places. So x is going to be 10.58. 18 times the sine of 54 would give me 14.5623. So y is going to be 14.56. Now, I have to make sure I have the right signs on my answer. This happens to be going backwards, so x should be negative. so negative 10.58. This is going down, so y is also going to be negative. So negative 14.56. So x is negative, y is negative, and I found my answers. So always make sure you go back and make sure you have the right sign on your answer, because these are going to end up being positive. But if you're like this one in quadrant 3, you went negative and negative, so both your x and y should be negative. So again, on number 11, we're calculating the x and the y component. So my x is going this way, my y is going this way. And again, we're going to use the cosine in order to find x and the sine in order to find y. So the cosine of 71 is going to equal the adjacent over the hypotenuse, so x over 57. The sine of 71 is going to equal y over 57. So 57 times the cosine of 71 and 57 times the sine of 71. So 57 times the cosine of 71 degrees for x would be 18.5573. So x is going to be 18.56, since I have to round that up. Over here, y is 57 times the sine of 71. So 53.8945. So y is going to be 53.89. My x is going in the positive direction, so it should be positive. My y, however, is going in the negative direction, so I've got to make that negative. So x is 18.56, y is negative 53.89. Number 12, same kind of thing. I want to calculate my x and my y, so I'm going this way for my x, this way for my y. The cosine of 59 is going to equal the adjacent over the hypotenuse, so x over 20. The sine of 59 is going to equal the opposite over the hypotenuse, so y over 20. So 20 times the cosine of 59 and 20 times the sine of 59. So for x, 20 times the cosine of 59 gives me 10.3007, so 10.30, rounding that off, excuse me, to 2 decimal places. Y is going to be 20 times the sine of 59, 17.1433. So y is going to be 17.14, rounding that off to 2 decimal places. Checking my signs, x is going in the negative direction, so that should be negative. Y is also going in the negative direction, so that should be negative. So x is negative 10.30, y is negative 17.14. 13, 14, 15 tell us to find the dot product of our vector. And when we find the dot product, basically what we're doing is we're going to multiply the ones in the same spots and add our 2 answers together. So I'm going to take 5 times negative 8 plus 7 times 9. So the x values I'm multiplying together, the y values I'm multiplying together, and I'm adding my 2 answers. So I would get negative 40 plus 63, 63 minus 40 would be 23, so 23 is the answer to my dot product. I'll use the dot product in some other calculations, but first they just have you practice doing the dot product. So number 14, again, if I'm going to find my dot product, I'm going to take the 4 times the 9 plus the negative 8 times the 5. 4 times 9 is 36. Negative 8 times 5 would be minus 40. 36 plus a negative 40 would be negative 4. So negative 4 is my answer to the dot product on those two vectors. And my last one here, finding my dot product, I have the vector 8, negative 6, and 4, 7. So I'm going to take my 8 times my 4 plus my negative 6 times my 7. So that would give me 32 plus a negative 42. And so when I add those together, my dot product ends up being negative 10. So dot product looks like it's telling you to multiply those things, but you're multiplying the first values together, multiplying the second values together, and adding those two answers. (16, 17, and 18) say to use the dot product to find perpendicular vectors. And if the vectors are perpendicular, the dot product always equals 0. So basically I'm setting up an equation where I'm finding my dot product and putting it equal to 0 and then solving it for my missing variable. So again, to do the dot product, I'm going to take the negative 2 times the 6 plus the 3 times the k. If it's going to be perpendicular, that has to equal 0. So I would get negative 12 plus 3k equals 0. I'm going to add my 12. So 3k equals 12 and divide by 3. K would have to be 4. So in order for those vectors to be perpendicular to each other, one is at negative 2, 3. The other one is at 6, 4. So again, I have the vector 1, negative 3, and negative 9k. I want them to be perpendicular, so their dot products must equal 0. So 1 times negative 9 plus negative 3 times k has to equal 0. So negative 9 minus 3k equals 0. I'm going to add my 9, so negative 3k equals positive 9. Divide by my negative 3. K would have to be negative 3. So if I have the vector 1, negative 3, I'd have to also have the vector negative 9, negative 3 in order for them to be perpendicular. And the last one, same thing. I have the vector 1, 8, and negative 9k. I want them to be perpendicular, so their dot product has to equal 0. So 1 times negative 9 plus 8 times k equals 0. Negative 9 plus 8k equals 0. I have to add my 9. So 8k equals 9. Divide by my 8. So k would be 9/8. Got a fraction on that one. So simply using our dot product, if they are perpendicular, it should be equal to 0, solving it for my missing variable.